Hello everyone, this is Tanu and today I'm gonna start a video of a topic called properties of liquids, and where I'm going to explain the important points of in properties of liquids, and watch the full video so that it will help you, and hoping that all my before videos are helping you all. So please do like, share and subscribe to my channel. So yeah, let's begin. In properties of liquids, what do you mean by liquids? So what is the main property of a liquid? So it has a definite size but not a definite shape, but it takes the shape of a container. It has a definite size, means the amount of a liquid what it has, but it will acquire a shape of the container. So here in the liquids, intermolecular space is bit more than the solids. Then what do you mean by liquid thrust? It means you will be having a liquid of any kind of a liquid surface. To that surface some amount of a normal force is exerted. That is what called as a thrust. It means I'm going to tell you a definition of it. The total number of the total normal force exerted by the liquid on any surface in contact is the thrust, and its SI unit is the same as a force, that is Newton, and dimension is Lm(T)⁻². Then what do you mean by a liquid pressure? It means, so we will be having some liquid, and at one point you will be having a liquid pressure. For that the force is acting normally per unit area around that point is called as a liquid pressure. So here is the definition. Pressure at a point in a liquid is the force acting normally per unit area around that point is called as a liquid pressure, and the formula is pressure is equals to thrust by area, or P is equals to HPG. Okay, then you can also write it as a thrust is equals to P into A, and SI unit is a Pascal, and dimension is L⁻⁻1 M(T)⁻². Move to the surface tension topic. First one is a cohesive force. It means, so you will be having some molecules of the same substances, and between that molecules you will be having some force of an attraction. That is what called as cohesive force. Definition is here. The force of attraction between the molecules of the same substance is called cohesive force, and the cohesive force is maximum in solids, lesser in liquids and very least in gaseous. Next one, adhesive force. It means opposite to the cohesive force, where the molecules of different substances having a force of attraction. Definition is the force of attraction between the molecules of the different substances. For example, sticking of gum to the paper and cement to the bricks and so on. So here the cement is one substance and the bricks is another one substance. Next topic is angle of contact. It means take some liquid and put into a container so that it forms either a concave shape or else a convex shape, and that angle between the surface of that liquid and the container is called as an angle of contact. Take an example for angle of contact, that is water and mercury. So you can go through that diagram there, and here the water may forms a concave shape, whereas mercury forms a convex shape. You can see there the theta, and that is how the angle of contact is measured. So angle of contact of water with the glass is 0 degree, and mercury with the glass is 136 degree. It is a very important point to remember for the CET. And next, what is the note means? To remember the point that angle of contact of a liquid which wet the glass that are always less than a 90 degree or else acute angle, whereas which do not wet the glass they are always obtuse angle, means more than a 90 degree. Then move to the next topic, that is capillarity. Taking a capillarity tube and filled with one filled with water and another one is filled with a mercury liquid. So when it is immersed in a water container, then there will be a rise in a water capillarity tube, and there will be a decrease in level in a mercury capillarity tube. So this process is called as a capillarity tube. So here is the definition. It is the rise or fall of a liquid in a capillarity tube immersed partially in the liquid due to the surface tension. And the points to remember is the height of a capillarity rises varies inversely as the radius of the capillarity. So formula is H is directly proportional to the T cos theta divided by dr, and therefore H is equals to 2 by G into T cos theta divided by dr, and the final formula is T is equals to HR dG divided by 2 cos theta. Next, to some extent for a particular liquid, T, theta and D are constant. You just consider it as a constant, and hence the formula is H is directly proportional to the 1 by R, or else HR is also a constant. Then what do you mean by surface tension? So when a free liquid surface is at a rest, then it is having a tendency to contract like a stretched membrane to acquire a minimum surface area. It means it is how much it is possible it going to stretch or acquire a minimum surface area. That is what called as a surface tension. And here is the definition for it. The property of a free liquid surface at rest having the tendency to contract like a stretched membrane to acquire a minimum surface area, that is called as a surface tension. And the points to remember is surface tension is measured as a tangential force per unit length acting perpendicular to the one side of the imaginary line drawn on a liquid surface. You can see the diagram there and you will come to understand what it is. And if the F means force is acting on an imaginary line AB according to that diagram, the length of a length, and then surface tension is equals to force by length. T is equals to F by L, and here the SI unit is Newton meter and CGS unit is dyne per centimeter. Then on what condition or what factor surface tension of a liquids are depends means first one temperature, second one contamination, third one nature of a liquid, and fourth one is as the temperature increases the surface tension decreases, and the work done while increasing the surface area of a liquid called as a surface energy, and surface energy is calculated by product of a T and A, where T is a surface tension and A is a surface area. Next, what do you mean by viscosity? It means some liquid is put into some container and there will be some layers one by one another one, and where the particles of one layer and particles of another layer going to movement, and there will be causing some friction, like vehicles are moving in on a road, so that there will be a friction between the vehicle's tire and a road. So likewise there will be a friction between the particles of one layer of the liquid and to the particles of another layer of a liquid. So that process is called as a viscosity. So which means its definition is the property of a liquid to oppose the relative motion between the different layers, that is what called as a viscosity. Then what do you mean by coefficient of a viscosity? The tangential viscous force acting on a unit surface area of a liquid layer moving with a unit velocity gradient. So here the viscous force is tangentially acting on a surface of the area of a liquid. So that is what's called as a coefficient of a viscosity. And what do you mean by velocity gradient? Change in velocity with a distance from before and after, that is what called as a velocity gradient. And here is the definition: the rate of a change of a velocity with a distance, that is called velocity gradient. And here is the formula for it, and F is directly proportional to the A into dP by dx. dP by dx means nothing but a velocity of a gradient. Then A means area, F means viscous force between the two layers, and therefore F is equals to N means coefficient of a velocity into A, and into dV by dx, where A stands for surface area of a liquid layer over which the force acts tangentially. So points to remember is, if A is equals to 1 and dV by dx is 1, then therefore coefficient of viscosity is directly proportional to the viscous force between two layers. Nothing but N is equals to the F. So the next point is, as the temperature increases, viscosity of a liquid decreases. And next one is, for gases, as the temperature increases, viscosity also increases. So these are all some important points of properties of liquids of a third chapter for the diploma students. And I hope that you all like this video, and do like, share and subscribe to my channel so that you will get notifications of my new video. And if you are needing of some other topics, and go through the playlist of my YouTube channel and check for the playlist, and you will get there. And please do like, subscribe and share, and thanks for watching the